Good morning or good afternoon, depending on where you are in the world. Thank you so much for joining us for this first series of webinars we're doing to introduce some of our clients to the new technologies that we're developing here at Scentroid. This one is going to be about our new drone-based air quality monitoring station, which we call DR2000. The format that we're going to follow is to provide you with some technical information and then take questions from you and have a discussion as you like. So with me here in our boardroom is Omid, our R&D manager and director of R&D department. He's been very involved in development of this technology. So he's going to be taking over and presenting to you the benefits, how this technology works, and everything about the DR2000.
Yeah. Hi, everyone. My name is Omid here. So just to give you an overview. So our feed that you see here, we're going to be presenting. You should be able to see my screen, which we're sharing a presentation slide with you. Also, on our site, there's a live video feed showcasing our actual DR2000 product over here. So just make sure that you keep an eye on those things while we go on. We have a chat window open here. So if there are any questions, I suggest everyone type their questions, and at the end, we will take them one by one. But in the meantime, I'm going to go ahead and start with the presentations. And I'm very excited to introduce our products to you today. So the goal of today's seminar is to introduce our new product, the DR2000. So this is a successor to our DR1000 product. I'm going to go over a few features, seeing what has been improved since. So the first and foremost important feature that we have in this product is the weight reduction that we've implemented. So we listened to our customers, and there was a need that we wanted to reduce the weight for increasing the flight time and operation practicality of this product. So what we did was we reduced the weight to almost 520 grams at minimum, and 640 grams on fully loaded, which is including all the sensors that it can have. So with this, by doing this, we can increase the flight time significantly, and we can have it to be more practical.
Because we can have a different kind of drone. Before, it was necessary to fly a commercial drone, the 8-propeller drone. Now, more mid-level drone with a lower weight capacity can also take over.
Next thing is that we've also implemented better communication capabilities on this. That compared to the DR1000, this offers more range and a faster and higher throughput communication with this product. In this drone, so let me give you an overview of this a bit. So the whole idea of this drone was that we could have this as a test bench where we could test our new sensor boards that we've developed in-house. And we found that they perform very, very well. And so we included them in this product. So this specifically refers to the electrochemical sensors. As we will all know that they're a little bit challenging to work with. But our sensor boards, using with them, we get a very stable and accurate readings from these sensors, and so we've included them in this product. On top of that, we also have like a improved particulate matter sensor here, as well as significantly shorter warm-up times. Before we had warm-up times in the range of hours. Now we have just came down to like a few minutes after startup time. As you can see here in the photo, we're using this black carbon fiber casing. We designed this in-house, so this is where most of the weight reduction has happened. It is carbon fiber, so it's very strong, and its aerodynamic shape allows us to reduce drag and have a better flight capability. Also, last but not least, we've improved the sample intake. As you can see, the probe in front, that's where the sample comes in. So what's different here is that we're not using a pump anymore. So we're using a negative pressure chamber inside that allows us to draw in very smooth sample of air that drastically improves the sensor response. So these are the highlights of this DR2000 product. Now let's just go over the overview of this and see what specifications we have. Yeah, so I just see one question relevant to this. Bob is asking that there's no separate inlet for PM. Is the main inlet for PM as well? So that's a great question. And yes, the same inlet as you can see here, all the sample is drawn through here, and both PM and gas sensors both take samples from this same probe. Yeah, thanks. Yeah, so the specifications. This is shared on our website, but just going over quickly to tell you what it can do. We can have 11 maximum sensors here. So 4 electrochemical, 1 carbon dioxide, 1 photoionization detector, 1 methane, 1 PM, which includes PM1, 2.5, and PM10, temperature, relative humidity, and a barometer for measuring the air pressure, as well as the altitude. So these are the type of sensors that we can have. And the sampling rate of this drone is about 1 per second. And with the ground station also receiving the data at a similar rate. The sampling probe takes samples of at least 2 liters per minute with a absolute minimum of 1 liter per minute flow rate. We have probe lengths configurable. So the minimum it can be 44 centimeters, or we can stack them together, have 88 and so forth. The size of the product, as you can see, is much more improved and smaller than the previous version. So at maximum length, we only have like 23 centimeters. And that's the length of the product. And so the time of flight, that's really dependent on the drone. For example, the DJI Inspire 2, we get about 25 minutes of flight time with that, which is the limit of the drone itself. But our DR2000 product can have a runtime of about 2 hours from a full charge battery. So I see a few questions regarding the drone, how it operates. So when we're going to show the products themselves, I'm going to explain how it is operated. So I think that will answer Florian's questions. Yeah. Cool. So the drone itself communicates with the ground station through LoRa communication. And then the ground station itself communicates to our cloud-based service via the internet, our Dreams2, which I'll be talking shortly. On board the drone, we have a 16 gigabyte SD card where we store the data locally as well. And just in case something goes wrong, or if a customer needs to have anything done locally instead of a cloud. So this product comes with a ground station, which is a 10-inch tablet and a ground station microcontroller, basically, and that's communicating with the tablet, with the drone itself while it's flying. And all the features of the DR2000 are controllable from that ground station. Yeah, so our product comes with the software for 1 year, which is called Dreams2. That's a drone information management system. And from there, we can control everything. And I'm going to go over that shortly. Our operating temperature range is about 5 to 40 degrees Celsius. Operating humidity 10 to 90%. Also, we can do auto calibration of this using our GD600 system. So if a customer purchases that as well, we can have that before every flight, that we can auto zero our drone before every flight. That can happen. Of course, just like our other products, our warranty covers this for 2 years, including all the parts and sensors. And the most interesting feature of this, in my opinion, is the mounting hardware, which is a customizable lid, which can be mounted on the in the Inspire 2 drone by default. So this is customizable. So if a customer prefers to use a different type of drone, this lid can be replaced to another system or design to mount on the different type of drone. But for the Inspire 2 drone, that comes by default, we have few redundant safety features here to mount it. So we have the mounting screws, counterweight ties, and also some zip type hook points for this to be safely secured. And of course, we have location and altitude-based sensors that will augment the altitude measurements based on pressure. And so when a customer purchases this, it comes with the DR2000 itself, the analyzer, the ground station receiver, the ground station itself, air sampling probe, charging adapter, the zeroing filter, safety ties, but of course it doesn't include the Inspire 2 drone. But that's an option that can be added on as well. And I've seen many questions before that, or concerns that what the range of the product is and how far it can reach. So with this drone, we were able to achieve 1.5 kilometers range. So if a drone can handle that, our product most definitely can as well. So I think that's far beyond any application that we've seen so far. Yeah, so from that, we have a recommended drone, which is the DJI Inspire 2 drone. We found out based on all the design criteria that this is the most efficient drone that we can use for practical reasons and also for operation reasons. The drone comes with a forward-facing camera, which we can have a live feed during flight, and also observe, see how the sampling is being performed. So this drone itself has many safety features that are very useful for our clients, which include like forward-facing stereo vision, downward vision system, upward infrared sensor. These are all for obstacle avoidance, and we can reach speeds of up to 94 kilometers per hour, and also safety features like returning to home, low battery, or loss of signal.
You want to take maybe a couple of questions while we...
Yeah. So I think this is a good point now before talking about our software to take a few questions here. So
there's a lot of questions.
Yeah, there's a few questions here.
One by one.
Yeah. Okay, so Florian is asking, can someone else control the drone with a different remote controller? So
we have it here, right? Like this is for the flying. This tablet is for flying, and this separate tablet is for the viewing the results. And the important thing is because we have separated the communication from that of the drone, that means that the unit is sending its own communication through a secure LoRa. So that's encrypted LoRa communication, long-range radio. So it doesn't matter which drone you're using, even if you're not using a drone, if you're just mounting it on a vehicle or walking around with it, it still would work. Batteries are all included inside the unit, so it doesn't take even power from the drone. The drone is just carrying it. So usually how we fly it is, for example, in our company, Omid is the only licensed pilot. So he flies on this one and somebody else looks at the data. It's just too much for one person to keep an eye on both things.
Yeah, but if a customer prefers to have a single person operation, that's also possible, where they can set up the DR2000 drone, the tablet first, and they can put it on the ground and just focus on flying and then come back and do the post-processing of data after.
Yeah, that's absolutely true. Yeah, you don't really need to keep an eye on the DR2000 on the analyzer. That's absolutely true. Sometimes, I guess, if you're trying to track a plume, then you might want a live feed where your flight pattern is related to what you're measuring. But otherwise, yeah, you don't really need to even look at it. You just start it up and just leave it alone by itself.
Yeah, great. Okay, next question is from Lucas, and they're asking, does that mean that the inlet has been tested to ensure isokinetic sampling of particulate?
Yeah, actually we did that, and we have a nice video that later we should show.
Yeah.
We do a comparison between our drone and a TSI unit as a reference, so a particulate instrument that has been accepted and calibrated. And we have a chamber where we do the testing like that, but we also do a lot of testing where we generate particulate, smoke, and other things. And we do it during flight. So the drone is approaching the smokestack that we created, and we do a measurement like that. So we do take that into consideration here.
Yeah, great. Next question is from S. Williams, and he's saying, is the inlet probe heated? So the default is that it is not heated. But the probe itself has a capability that we can add something, a heater to this as an option if a customer specifies that. But that will drastically reduce the operation time of this because of the nature of it. But in terms of the measurements, we have a relative humidity sensor on board, so we can have a capability to monitor the humidity, and in case if that's really affecting the PM readings, we can have awareness of that and do some post-processing of the data later on. But yeah, that could be an option there as well.
So yeah, the only reason, I mean, you would only need it in two modes to heat the inlet. Is one is, yeah, as Omid mentioned, if you have water droplets, like if it's raining outside, typically even the drones, you don't really fly in heavy rain, but it could be one. The second one could be that you are sampling from a hot smokestack or something like that you don't want the condensation. The length of the tube is quite low, and we kept everything, so there's no metal pieces that are coming in contact to create a condensation point like that. It will, of course, if the probe is in a very hot stack, it will create an issue. But since the drone can only take up to 50 degrees, we imagine that these stacks are mostly not going to be from a furnace or something like that. So I doubt the second issue will come up where you have a lot of condensation. It will be more towards PM readings being affected by water droplet, which Omid mentioned. We can take care of it in post-processing if it's necessary or at the heater.
Mm-hmm. Yeah, exactly. Next question is from Niels. I hope I'm pronouncing your name correctly. You say there's no pump, but how do you create the negative pressure to draw in the air? That's a great question. So the air is being drawn in with a fan. So the fan is placed at the outlet on the back of the DR2000, and then it creates a negative pressure inside the whole chamber in the box. So the box is sealed, and the only place for air to come in is through the probe. And that's how we take air inside. Yeah. He's also asking, is the tablet Windows-based or still Linux operating system? So the tablet right now is running Android operating system, and we have a DR2000 app that we developed in-house, and that's running on the system. This app basically receives data from the drone, and then it also stores it locally and also sends it to our cloud system, Dreams2.
You can run that app on any Android device, even on your phone. You can connect the ground station. So the ground station is going to be the smaller. So this piece is the ground station, which is a small receiver that converts the LoRa signal, the long-range radio, and feeds it through a USB back into the tablet. So in this case, you can use any tablet you want. We do provide a rugged tablet or a tablet with a rugged case that has been already set up.
Mm-hmm. Yeah, exactly. So next question is from Bob. He's asking, outside of the 1.5 kilometer range, our data is still recorded on the onboard memory. Yes, that is true. The data is always being stored on the onboard memory, and that's every second or two. And they're all timestamped and location stamped, so we all know exactly where the data is applied to. So in a case where the DR2000 loses connection with the ground station, we would get an indication on the tablet itself that it has happened, but the drone itself still continues to record data. And for customers who would want ranges of up to 500 kilometers or even more, that's also possible, but we will have to work on a case-by-case basis if what we can do about those things. Next question is from Jason. He's asking, how long does it take to charge the DR2000? So there are a few things here to charge. So the drone itself, that takes about, I would say, an hour to charge. The DR2000, it takes about 30 to 40 minutes to reach 80% of its full charge, and about almost 50 or 1 hour to reach full 100% charge. Yeah. And of course, the tablet itself needs to be charged as well. Yeah. Okay. Next question is from Chandra. He's asking, can it handle failure modes?
Maybe communication failure.
Yeah, if you're referring to communication failure modes, we have mitigations for that in the app that we can detect. Oh, if the communication wasn't properly done, we actually show a message saying that the last packet was had an error and it wasn't received, and we have an indication. But I mean, I'm not sure what other failure mode is referring to. But if you can ask me a question, and again, I can get back to you with that. Next question is from Daniel. He's asking if the analyzer module could be add or
to
other flight drone.
Any drone
that is capable of this payload. is okay to use with this drone. Yeah.
We even have clients using it with balloons, like weather balloons, with cars in Poland. They mounted it on top of police cars. The vehicle doesn't really matter. It can be anything. It doesn't need to be a drone, even though we kind of market it as a drone based. It can be any vehicle that is moving.
Yeah. Great. Next question from Emma. How does the DR2000 mount with the camera still mounted on the drone? So that's a great question. So I'm going to go over, just walk over here to show you how it works. So as you can see in the Inspire 2 drone, the camera is in the front, as you can see here. I hope it's visible.
Yes.
Yeah. So once the DR2000 is mounted, I'm just going to showcase to you actually how the lid is being mounted on. So it's very easy. So it's basically just a matter of sliding it over. Okay. Perfect. Right, so there's the lid, and then we have the DR2000 product itself, which basically comes here, and then the customer would screw it in over here. So this is how it would sit. As you can see, the view of the camera is not really blocked. So even when the camera is looking downward, we still have good coverage of the view in front of the camera. So we designed this box to not interfere with the drone's vision system at all. So we have this forward vision system in the front, and also there are vision systems at the bottom where there's cameras for ground detection. So we designed this to not interfere with any systems of the drone itself. So we have full functionality of the drone as well. We have this LED status indicator in the front as well. So when the drone actually is looking downward, we can actually take a peek and see what the status of the drone is during flight as well, in case something were to go wrong.
Because that ties back to that failure detection.
Yeah. Mm-hmm. Okay. Okay.
I think more questions come as we
answer
them.
Very good. Very good. It's very good. Okay, next question is from Bob again. Are there any of the sensor options new compared to what was available with DR1000s? Yes, so we have different arrangement of sensors in DR2000. The most important being that in DR2000, the sensor responses are much more improved because we're using our new technology here in this drone as well.
And lower detection thresholds. The type of sensors that you can pick is from our extensive list. I think now it's like 70 sensors on it or something. I have to look.
It's on our website, the full list. So
the full list is on our website. Yeah, so it's an extensive list. You can pick from that the type of sensors that you're going to use. We kind of share that list across all our products. So regardless of if you have a handheld analyzer or a drone, it's going to be from that. This unit and some of our newer products like AQ Safe use, as Omid mentioned, newer chips. So you will have much better response time. For example, ammonia can go to a few ppb detection where before it was hundreds of ppbs of detection. But the ammonia is still there. Yeah, like all the same sensors are there. They're just improved.
Mm-hmm. Yeah. Okay, next question is from Javier. It seems that the DR2000 no longer accepts MOX sensor. Can you comment on reasons excluding technology?
MOS sensor, I think.
Yes.
Yeah, it does take, we can include a MOS sensor, but we are kind of focusing a lot more on the electrochemical side. While we do have room for a MOS sensor, the MOS sensors, especially for DR2000, they take a lot of power and they burn like close to 600 milliamps up to 1 amp. And why that is the sensor itself needs to keep warm, keep hot really, where electrochemical sensors only take a few milliamps. So this makes it so that it's a very power hungry sensor. It's not differentiating between a lot of different gases. So for most applications, it's not a good sensor to use, but we have left room for it because some people want to use it for odor detection where they don't want to know what it is. They just want to know, is this place more smelly than another place? So you can still use MOS sensors and we have place for them. We just have been a lot more focused on electrochemical sensors.
Mm-hmm. Great. Okay, next question from Sunish. What would be the recommended or optimal flight speed for good quality measurements with a full load of sensors? Regardless of the sensor configuration, the drone is rated to fly at its rated speed for the measurements to be taken. But usually the application is that we fly the drone somewhere and then we just hover in that area to get readings over a couple of minutes, then fly to next place. But if you wanted to fly the drone like over a constant area, a good speed, like not too high, not too fast, obviously for safety, but that doesn't really matter because our drone can take samples as it needs.
Yeah. So what Omid is saying is that the probe itself can handle 100 kilometers per hour even. It will compensate and suck in more air if it needs. But the thing is that the way that you do a sample depends on the application. Sometimes you have a stop and go where you would take a grid pattern on top of your sample area and you would go, let's say, 500 meters and then make another measurement. You can hover slowly over a pond, for example, where you're taking a smeared measurement, where it's kind of averaging out this readings over a large area. And that would be probably like 2-3 meters per second. Mm-hmm. So you would go a bit less speed than 100 kilometers an hour. Mm-hmm. But obviously, you don't get good results if you're going fast because you don't know what that peak was. Where did you take it? It was so fast that by the time the sensors reach, your drone has moved 50 meters from where that was.
Yeah, great. Next question is, can the GPS location of the drone be integrated with Google Map API? Yes, it can, and we've already done that here as well. And the next part is, as the lat long that is given in 10-digit values. So the latitude and longitude here, we have we report them in decimals. So they have, I believe, 6 to 7 decimal places, and that's how we record them on the database and also what's shown on the screen as well.
I think Omid will go over the software so you can see. Yeah. So there are two software. One is the ground station, where you can still see through Google API the location of the drone, a heat map and everything. And then we have a cloud-based software, which Omid is going to go over, which will take the results and show those as well through actually using Google APIs to give you contour maps and heat maps and stuff like that.
Yeah,
it's a big improvement over the DR1000 software as well.
Yeah. Next question is, has the DR2000 platform been tested with a parachute? At this point, we haven't done that test, but that's definitely what we're looking forward to do as well in the near future. So we'll keep
we do vibration and drop test, but not the actual physical parachute. We just don't have yet a parachute.
Yeah, I mean, if you have a specific application in mind or a question, just let me know, and we can talk about it later in detail or at the end of the presentation today. Next question from BT2521, any wind or temperature sensor? So we do have temperature and relative humidity sensor, and we do have a plan of including a wind sensor on board as well, but that's still under development, and we will be as an option on this drone as well. Okay, next question. If you fly through a moist plume, is there no risk of short circuit with the batteries exposed to the aspirated air? Those are great questions. So we treat our PCBs and electrical connections so that they're not really affected by the moisture present in the air. But the thing is, our drone is rated to fly within the range of humidity that we specified. So if you exceed that range of humidity, obviously there could be something issues happening, but it's very unlikely.
But this moist air is also not going over the batteries and the circuit. So the sensors are exposed, but not the top electronics, not the batteries. They're in a different place. They're sealed from that sample air.
Yeah.
I think that's it.
Yeah. The next part is, can you still collect sample bags with the DR2000? So no. Currently, the DR2000 does not have that capability. So people who are interested in that, they usually do that only for the bagging. So we have the DR1000 product for that still going. So this is not a replacement for DR1000. So we still have that going for people who are interested for doing a sample bag.
It's something we're looking into, though,
Yeah.
to include that. The main goal was to get it to that 500 grams. So we had to cut a lot of stuff. But now that we wanted to get it to 700 grams or less, but then Omi did such a great job. We got to like 520. So now we have a little room. So now we can look into how we can integrate a miniature pump or something to allow for a bag sampling, because we know a lot of our clients were using that.
Right, the question just came in, and after this, we're going to move on to the rest of the presentation. So the question is saying, do you have a noise sensor which can be mounted for monitoring noise? Although it's possible, but I don't think it would be really practical, because the drone itself generates a lot of noise that would mask any other noise in the environment. So I don't think that would be really a practical solution. Yeah. Okay. So just moving on with our presentation here, I'm just going to talk about our Dreams 2 software and the whole module here. So in this screen, you can see the ground station tablet showing our app that is displaying the gases here. So what is Dreams 2? So the Scentroid drone information management system basically is used to view the historical data, run diagnostics, configure and set alarm levels for the DR2000. So it comes as part of the DR2000 package, and this software is installed in our onboard server, and we have access to the cloud-based server as well for viewing the data. Yeah. So the DR2000 ground station. So this is a Flying Laboratory aid. So where the operator can look at this and operate the DR2000 here. So this app serves with the primary assistant for any Flying Laboratory unit. So it includes all live data as well as the historical data for all the sensors, including GPS, position, altitude, temperature, and humidity as well. So you can kind of see here that as the drone is flying over, we have these like points on the map showing the historical data being recorded as we move forward. So sampling with this Dreams 2 is much more easier now, because it's an all-in-one solution here where we have everything put on one screen and under control. We can command the drone to take samples or to perform routine maintenance, such as calibration sensors, like the re-zeroing and similar as well. Also, the very prominent feature of this app is the advanced mapping, where we are allowed to use the altitude data to have a 3D dimensional map of the system, where we measure the gas sensors and we see, as you can see, it's different heights, what different kind of pollutants we have been measured that way. So from this data, we can also generate a heat map where we cover basically a ground that we flow, and then we can see what kind of pollution exists at what locations. More so is the data analysis and graphing. So this app basically automatically syncs with the cloud software and database, and the data is transferred back and forth automatically in the background without the user intervention. And this way we can have all the data recorded for analysis later on. So what kind of analysis can we do? So the Dreams analysis software here, this is the interface, as you can see here. So if you have an internet connection on any device, you can access this on our server by just entering a web address, and you can log in with your unique ID and password, and you can access these vast features of this software here. So all of these include like historical records, basically what flights have been performed and what measurements been taken before, the alarms, and the locations of everything as well. Next is for data. It's much more easier to go back and find specific data. For example, let's say you flew over some field and you weren't really expecting to get any measurements there, but here it's much more nicer to figure this thing out, because we have a map view here that you can see live, that if you flew over, and then you can see the data live linked to these as well. So it's much more easier to figure out and diagnose things. Of course, the last but not least is the advanced mapping feature, as you can see here. So if the drone flies over this path and it measures different pollutants, and then you can automatically create a heat map of this location as well. So What are the applications of this DR2000? So in the past, we've had a lot of interest in urban monitoring, where we want to really know what's going on where we live, but oftentimes it's very difficult to reach those areas. So this drone is very suitable for this because we're using a lighter drone, now it's much more safer to fly it over people and around the city structures with all the safeties included. So this enables us to really monitor the real-time pollutants happening around us. Of course, one of the most important ones here is the odor monitoring. So there's a lot of noise and sources from our environment. For example, this chemical plants or asphalt plants, pulp and paper. So with this drone, we can fly remotely and go to these sites and basically kind of monitor, see what's going on and where the sources of these odors coming from. Especially that during dynamic days where the wind is blowing in different directions, we're able to actually fly downwind and see actually where the impact of this pollutant are going to, like what neighborhoods in the city is affecting and all of that, yeah. Of course, the other application is the wastewater monitoring. The other issue with this is the odor, basically. These facilities generate a lot of odors, and of course, measuring these things as well is very important to have as well. One of the best features of this drone, in my opinion, is that because it can fly over large areas and cover large areas and remote areas, is that we can go fly along the pipes and then we can detect any leaks in the pipes as well. So previously, this has been done by technicians going around actually on the ground following this, but now with the drone, we can quickly reach these locations and like prevent any damage or structural abnormalities and find them very efficiently.
And if I can add to that, is we also worked a lot on the response time of the sensors, and as Omid mentioned, the way that it takes a sample. So it will actually react to the gases a lot faster than DR1000 or anything else that we had produced before. So it allows for this kind of like, for example, pipeline leak detection, because as you fly, you need to be given an alarm of exceedance right away. So the response of the sensor has been much improved for that. And then the equipment itself, the tablet, has features to set up alarm levels. So you say, I want, for example, PID reaching 100 ppb to give me an alarm. And as soon as it hits it, you will actually hear audible alarm from the tablet. It will start like a siren. And you can tell that you need to go back and monitor that area in more detail.
Mm-hmm. So the next area, which is very interesting, is oil and gas. So these plants, petrochemical plants and oil and gas plants are crucial, obviously, but then they produce a lot of hazardous pollutants in the atmosphere. So most of these pollutants come from their stack, and it is very important to be able to detect these and also monitor them for their strength and leaks or unexpected release of these pollutants in the atmosphere. So with this drone, obviously, it's possible to still, just like DR1000, to fly near them. But with the difference that it's going to be a much more accurate reading compared to before. One of the most interesting other application is agriculture, where we have a variety of pollutants coming from bio sources, mostly referring to like odor, noisance. So the DR2000 can provide an aerial monitoring of both odor and pollutants in agriculture facilities. So often these facilities are remote and also cover a very large land area. So it would be much more suitable to use a drone as opposed to going locally and figuring out what the source is.
Also is more interesting for the cows.
Yes. Of course, yeah. And then we have the compost as well. Yeah.
A compost, one of the, in landfill and compost, we have used this, and I know some of our clients have used it, is for methane detection from the landfill area or a big compost area. We worked a lot on our methane sensor, and I believe the lowest detection is now, do you remember?
For methane?
For methane. because it was from hundreds of ppm, and then we moved it to under 1 ppm.
Yeah, it's under 1 ppm, but I don't have exact figure with me right now.
It's under 1 ppm, which if you're familiar with gas sensing, you know, for any gas sensor, compact gas sensor, to get under 1 ppm methane, it's really special. So we worked a lot, and our compact gas sensor can get to under 1 ppm, and we have a tunable laser that can go even to ppb levels for this. So it allows you to cover the compost or the landfill area, and because of the fast detection of methane and the low ppm level, sub ppm detection level, you can actually determine where the methane pockets are that are coming out. So this has been one of our strongest applications, where we sell lots of drones for this particular reason.
Yeah, very nice. Yeah. Also, the last application I have here on this slides is about first responders. So in the event of, for example, wildfire or a controlled burn, it is very, very important to understand the dynamics of it, to see how much the weather is influencing it, where the wind is taking the fire, and all of that. So a drone flying around, we can have the real-time information of how dry an environment is, or the wind, where the wind is blowing, and kind of monitor the progress of this fire, and like focus the first responders' effort on certain areas that will be most effective.
Absolutely. And wildfire, as well as other, we've had the same for chemical. You know, if you have a fire and you expect release of hazardous chemicals, you can have this as a first responder for the fire department. We also had where they are excavating something that has a biohazard or chemical hazard, and they're using the drone in their excavation, so to make sure that it's safe for the operators. So in both cases, it can be for wildfire or for fire from a chemical plant.
Yeah, great. Okay, great. So at this point, we reached the end of our presentation. Now I'm going to go continue on with the questions here. We left at, there was a few questions coming in.
No, I think much higher, no? So not a few, it's a lot more.
Here. There's more. Great. Okay, so here's the question, I think it's here. So is the Dreams 2 software available for DR1000? Yes, that is also available. You can also configure this for the DR1000 as well. Yeah.
So if you right now buy a DR1000, or even if you had an old one, you can now run the same ground station and cloud software that is used for DR2000 on the DR1000. They send the packet in the same structure.
Yeah. Next question is from Javier. He's asking, which sensors do you recommend for odor detection? Do you have any AI algorithm to convert from single gas concentration to odor intensity? So this really depends on the application, but for example, the most interesting gases are H2S, sulfur gases like SO2, that are really the nonsense for contributing to the odor.
But we do also have an odor concentration.
Yes,
that's true. And we have collected a lot of information, a lot of data ourselves that we use to create. So if you say I have, for example, a wastewater treatment plant, we give you the sensors you need, like you need H2S, DMS, methane, a couple of other ones. And not methane, sorry, H2S, DMS, ammonia, VOCs, and something else. And we have already pre-programmed based on wastewater, because they smell more or less the same. So same as compost, same as pulp and paper. So we give you the list of sensors you need, and the unit will calculate the odor concentration, and it will be like another metric. So if you want to heat map based on odor concentration, or put alarm settings based on odor concentration, it will be as if it's a separate sensor measuring that.
Yeah, great. Next question is, how does the modeling display multiple commodities in a complex emergency? I'm not quite sure what you mean by that.
I do. So I work more on the software side with the software guy, so I'm going to take some of those questions. So when you see those graphs, you can graph a single sensor. For example, you're looking at the 3D graph, right? And you have those little dots, and they make a 3D point cloud of the area that you're doing, and they change the color based on the concentration of the sensors. So how they combine it is sort of like how you combine to get AQI, air quality index. You set certain limits for each sensor. So you say from here to here is green, from here to here is yellow, then it's cyan, whatever. And it will take the maximum of those and present it as the color. So if H2S goes up, it will become red. The whole point becomes red. So that's one way to do it. You can have individual alarms for each sensor, and if any of them exceed, that's another way to do it. And a third way is to treat it as one metric, kind of like odor. So you can have where you combine them to give you like an odor reading, and if the odor reading exceeds, you will get an alarm. So even if like two of them go to 50%, but the odor goes to 100%, you get an alarm. So I hope that kind of answers that question.
Yeah, great. Next question is, what is the flight time for the Inspire 2 with the DR2000? So the flight time here, normal condition, like no wind, it's about 25 minutes with the DR2000 attached. Yeah.
I think by itself,
it can go up to 2 hours. So if you have like multiple batteries, for example, you can quickly land back and swap the drone's battery and then go flying again without turning off the DR2000 itself. Yeah, great. Okay.
Yeah, there you go.
Okay, can the Dreams 2 print out a reporting PDF and or Excel format that includes a map of the area surveyed? So our Dreams 2 software does export the data in Excel format, and the map is featured in our cloud-based system. So if you log into our cloud, you can actually see the map and all the historical data as well.
And the PDF.
So
it creates sort of a report of the flight. So it has certain predefined section, like how long was the flight, what area it covered, how many kilometers, things. What were the exceedances? So these were things that exceeded that limit that you had set. Create the heat map, create the point cloud, and it will sort of auto-generate a report for you. So this is the new feature also of the. So this is only for the cloud software, of course, not on the tablet. The tablet is mostly just for live viewing, and then it auto syncs to the cloud. And cloud, you can do these more advanced analysis.
Yeah, great. Next question is from Lucas. Do you have an odor metric for cannabis facilities, similar to wastewater compost?
Yeah, actually, we do. We did a big study here in up north in one of the cannabis grow facilities. And we collected a lot of information, so we know which of our sensors react to which part of the process, like growth, drying, extraction, And we did develop an odor because we had both olfactometric and sensor-based readings. So regardless of which of our products you take, a handheld analyzer or a drone, we now have that recommendation of the sensors and the odor calculation already done.
Yeah, great. Next question is from Hassan. Any issue with restricted flying zones for DJI? So about flying the drones, it really depends on your local government and what the restrictions are in place. So that's independent of what our product is. So I recommend that you check your local government for that kind of restrictions. But typically, what people do, they get a pilot certificate, at least in North America, to get this license and restricted flying zones covered as well. Okay. The question from Jonathan is, do you have any examples of the cloud?
He also said amazing.
Amazing as well, yes.
Read amazing.
Yes.
The example of the cloud, we do have another brochure we can send for the Dreams 2. We should have another one on the software itself. We wanted to keep this kind of short, so we didn't go through the cloud software in detail and how it works. That would take another half an hour by itself. But maybe we should do that. We'll have another seminar maybe to go in more details and load up example data and show you how the AI works. It does have a lot of really cool features that we work very hard. So maybe on another seminar, but we can send you the brochure right now.
Yeah, for sure. Last question here is, is there available data showing results from fixed sensors and drone system? Does the drone system needs to set longer time before recording for data, or 2 to 5 seconds is enough to present reading on one point? So basically our drone communicates with the ground stations, and the ground station receives data every 4 seconds. So if you hover in one area for like maybe about 8 or 16 seconds, you can collect maybe 2 to 4 like data points, which I think it would be enough for that, representing that area. But of course, longer would give you a more accurate reading as well. In terms of your first question, not quite sure if I understood it correctly, but
maybe a comparison test?
Yeah, we do have comparison tests.
We do comparison tests. I mean, that's how we even calibrate, right? We put this inside the chamber, and we have our, let's say, NOx analyzer, a US EPA analyzer, and we match the two together. So we do have data like that. There has been studies by other, like the Italian Research Institute, on putting the drone next to a station in the ambient environment to do that. If you mean by flying over a ground station, you can't really get a lot of, I mean, you can, but you'll get like, let's say 10 minutes of hovering, and most ground stations are reporting every few minutes a data point. So you have like 10 data points. So most of our comparison has been to put the unit next to it for extended period of time, or to cover a bigger area. But we haven't been flying over a ground station for a long time. This would work great with our modeling software.
Yes.
That's great.
That's good. Yeah.
I mean, read the positive one too,
yes.
Not just the questions.
Yes.
This would be great. Thank you.
Yes,
yeah, see, all of those are great. Was that the end of it? Yeah.
Okay.
So we can wrap up.
Yeah. So great.
So yeah, thank you all so much. Thank you, Omid.
Thank you, everyone. Yeah.
If you have any other questions, like you might come up with something else in 10 minutes or an hour, you can always email us, info@scentroid.com, and we'll pass it on to whoever can answer the question best. I think you're going to send some information as well. Yeah, so he's going to send, Matthew, our marketing director, is going to send an email with more information and a brochure of the software, DR Dreams 2 software. And we will see you on our next product. We have a few products. We've been very busy during this COVID time, so we have developed a lot of nice stuff. So we will see you on the next product presentation. Thank you so much for attending.
Yeah, thank you everyone for joining and listening to us today. Yeah.
Bye for now.
Bye. Bye.